In the previous video, we spoke about the default constructor. Let's review very quickly what it is. So if you go to the member class, you can see here under the class member, we actually declare so-called attributes or class level variables. We're going to see exactly how you can manipulate them a little bit later. Okay, the list of attributes define the structure of every object that can be instantiated from the same class. And then under the section for constructor, as I recommend, you can see here we didn't declare explicitly any constructor here. By default, there will be a so-called default constructor available for you. And we spoke about how to use it to create objects in the previous video. You can review it before you move on if you got any doubts. All right, so in this video, we'd like to talk about how you can customize the constructor so that you can really initialize certain attributes when you create objects. That'll be very actually useful constructor to have. Let's see exactly how we can do it. Right, let's maximize the member class over here. And I'd like to give you just examples, two examples about how you can create customized constructors. Let's see. So number one, constructors are just like a specialized kinds of methods. I would say in principle, if you want other classes in order to if you want to allow other classes to really create member objects, for example, in that case you should really make your constructor public. I would say there are very rare cases where you should really make your constructor non-public. So by default, you should every constructor should be public. So later on, we're going to talk about whether a particular method, either accessor method or mutated method, should be either public or private. I will speak about some principle later. But for now, we only talk about constructor. In principle, every constructor should be public. Okay, let's do that. As opposed to private, you can see for the attributes, which I already explained in the previous video. Okay, so now let's see. We want to declare our first customized constructor. You're going to put public, meaning that any class, either in the same package in the model or outside the model package, either in the JUnit test or maybe in the console apps, they can definitely use this constructor here to really create member objects, right? That's what public really means. Let's put public here, and then the name of the constructor must be identical to the class name, the name of the class over here. So we simply say public member. Okay, and then you have to give a list of input parameters, meaning that in order for you to really create a member object using this version of constructor here, what input value do you expect to be passed? Okay, let's say we want to have two versions of the customized constructor. Version number one, we want to have let's say these four. Let's say only these three. Let's say I want to initialize the ID and also the membership type and also the balance over here. Let's say that's what I want to do. Okay, so let's do it. So I would say simply declare the input should be of compatible type for the parameter. Okay, let's say we're gonna follow the following order. Let's say integer ID and also character the type and also double the balance. Okay. So here, I want to introduce a keyword called this right away. Okay, how to use it. Okay, when I visualize the object creation, you will see exactly how to understand the this keyword. Let's now first of all understand there is a potential ambiguity over here. You can see here when we declare the parameter, for example ID, there is another ID that's of the same name at the class level. Let me be a little bit more precise over here. We got two IDs in the same member class over here. Under the member class, this ID over here is an attribute, meaning that every method should be able to get access to it. So that's ID, right? So that's why when you put your cursor over ID, it does not automatically select the ID over here, right? And also vice versa. When I click the ID over here, it does not really select the ID over here. So as far as a Java compiler is concerned, so these two IDs are considered as two separate variables of different scope, more precisely. Okay, so the ID over here is so-called attributes versus the ID over here is a parameter. So this ID here is only visible within the method that the constructor that we are defining over here. So now, how do we say whatever ID over here, the user passed, for example, maybe 1, 2, 3, 4, 5. How is 1, 2, 3, 4, 5 being the ID going to be stored into the ID as the attributes, right? That's one question here. How do we do that? So a keyword that's very fundamental for the OOP in Java or any other programming language that will actually support OOP is called this. Okay, let me write it down, and then I'll visualize in a moment. Okay, so what I want to say is I want to say this. So this denotes so-called context objects. I'll explain what context object is in just a moment. Okay, context simply means whatever we're talking about right now, right? Whatever that's relevant. Context object this dot ID is assigned to ID. Okay, it's really important to see this right away. You can see the way Eclipse really highlight the ID over here, and the ID over here is different. You can see if you move your mouse over, put your mouse over here, you can see the ID here. If you put it at the same time, it's going to tell you that it's really referring to this particular ID that's declared in line number 12. So that's the attributes, right? I want to say over here, the left-hand side, this ID denotes the attributes ID. Whereas, if you go for the ID over here, you can see if I put my mouse over, it's referring to this ID that's declared at the method level, at the constructor level. Okay, whereas right-hand side, okay, let me just make it a little bit grammatically correct. The left-hand side, this ID denotes the attribute ID. Okay, whereas right-hand side ID denotes the input parameter ID. So it's a very important concept to really note, right? Also, the tool, the Eclipse tool, really helps you identify which one you're referring to. So what we're saying is, whatever ID that's actually passed by the caller, by whoever is calling this constructor over here, we're going to see that in the console application and also in the JUnit test in both contexts. Okay, whatever that's passed is going to be assigned to the attribute value for this particular object, the context object. But we're going to visualize that. For now, I just want to mention that verbally quickly. Okay, and then we're going to do something similar for all the other two. You can see we also want to initialize the type to the attribute type. And also we want to initialize the balance over here that's provided by the caller, and then we want to initialize for the balance attribute here. Okay, let's write it down. Okay, at least syntactically you will know what to write. So this dot type is assigned to the type, and also this dot balance is assigned to balance over here, right? So now if you move, you can see ID is referring to ID here, and also type is referring to the type over here. You can see the highlights, very useful highlights by Eclipse. It's not arbitrary, right? It's definitely informative. And also the balance over here is referring to the balance that's declared in line number 14. And then we got ID is referring to the parameter here, and the type is referring to the parameter here, and also balance is referring to the balance over here, right? Hopefully that's clear to you. All right, so this is our first constructor that's customized. However, I have intentionally actually restrict our focus to this class only. So you can see there is no compilation error for the member class. Agree? There's no red cross. However, let's switch back to the package explorer. You can see we got compilation error in member app and also test member in both of them. All right. Let's say for example, let's go to member app so to see what the errors are. Very strangely, so if you move your mouse over, it tells you the constructor member taking no parameters is simply undefined. All right. However, it was defined in the previous video, was it not, right? So here is the story. That's really important. That's why I want to make sure you finish the previous video before you see this video. It's really important for the sequence. What's happening is as follows. By default, let me just select this and then control / let's put this into comments. If there was no if there was no constructor explicitly defined, you can definitely use the default constructor like this. You can see there's no compilation error. However, as soon as you actually declare any customized constructor over here, the default constructor simply disappear. They simply does not take any effects anymore. You just cannot refer to them unless you actually want to define some constructor that looks like default constructor. Let me show you right away. Okay, you can see right now, as far as the compiler is concerned, the only constructor that is supported, that supports member creation, is only this version over here, which will take integer ID, character type, and also double balance over here. What if we also want to make this available as well, so we can still keep our work valid from before? The way to do it is go back to member here, and then, so now what I would do is I would say, so here let's say this, as soon as a customized constructor is declared, the default constructor is disappears, is inactive, is ineffective. All right, so now if I want to put it back, okay, I just need to explicitly declare that. Okay, let me do that right away. Okay, so I can say public and also member, and then you simply do nothing and explicitly declared default constructor. All right, hopefully you see the idea. So now if I go back to package explorer, you can see the member app and also the JUnit test. Actually, both of them will now compile. So now what we are really using over here, new member, we are really calling the constructor. Which version are we calling the constructor? We are really calling this version over here that simply does nothing. When we say does nothing, you will simply leave all the 6 attributes initialized to their default values without any particular value. On the other hand, this second version over here is going to take whatever values that will be passed by the user of this constructor, and then they will pass some specific value, which I will show you. All right, so that's about this one here. And let me now try to use this second version over here. And then we need to visualize that very carefully for the one and only time. And then later on, we're going to use the more abstract way of drawing objects. Okay, but we want to be very thorough for the very first time. What I will do is I'm going to actually, so this member app over here, if I go there, okay, let's rename it to be member app maybe 2, member app 1. So that's a previous version. Rename, and then member app 1. And then continue. All right, so hopefully remember how to rename in Eclipse. We have done this for many times already. Okay, and then you can copy this class, and then inside the console app, let's simply say paste, and then member app 2. Okay, and then let's go to member app 2. Let me close others as well, and then close others. Okay. So now, rather than calling the default constructor, I'm going to call the customized constructor over here. And then I'm going to say member 1, member 2. Let me keep the member 1 and member 2. But now I'm going to call the different version of the constructor, right? So let's remind ourselves, what should we pass as input? You can think about we are now acting as the user of this, the customized version of the constructor. So let me remind you very quickly, or remind ourselves quickly. We need to pass the ID and also the type and also the balance, right? Let's now do that. So ID, let's say just it's gonna be some unique ID for every member. So let's say 1, 2, 3, 4, 5. All right, and also the type of the member. Let's say it's a silver member, okay, and also the initial balance. Okay, initial balance can be, let's say 100.0 for this particular member over here. All right, and then let's say the second one, it's gonna be should be a unique number. Let's say 23867, right? It's definitely unique, right? Or you can simply say 1, 2, 3, 4, 6, right? It's also different, right? Let's say it's a bronze member. I would say B here, and then 100. Let's say 200.0. So we got member 1 and member 2. We can make it more interesting. We can simply rename member 1. So click on member 1 and right click and say refactor. Okay, let's say member 1 over here. Let's say Suyang. Okay, and then for member 2, we also rename it, right click, and then refactor and also rename. Let's say Yuna. Okay, we got Suyang and Yuna. We got 2 different members over here. All right. So now what we're going to do is we're going to see exactly how to visualize this, but let's review very quickly how to use this, use the Eclipse debugger to do it, right? Apparently we can see Suyang and Yuna, they will be different objects, right? Just for the same reason as we explained in the previous video, right? And so that's why Suyang equal Yuna should be false, whereas Suyang not equal to Yuna should be true, because we talk about 2 different objects. What I want to show you very quickly is something you can also do by yourself as well. Let's simply just do the following. If I just put a breakpoint in line number 9 over here, and then I'm going to debug, run the debugger. Okay, so right click on member app 2, and then I would say debug as Java application over here. And then I'm going to switch the context to the perspective to debug over here. So now we are in line number 9. Okay, right before we try to create an object called Suyang over here. So you can see under variables, we don't have Suyang just yet. And then as soon as I say step over, you can see Suyang has been created. And now if you expand the objects over here, you can see we still have exactly the same structure as we saw in the previous video. We got balance, height, ID, name, type, and weights. However, you can see the values over here is a little bit different, right? The balance is no longer just default 0.0 as before. And also the ID has been set up properly into 1, 2, 3, 4, 5. And also 0.0, also for the type, character S rather than nothing as before, right? So that's something to note. And it kind of intuitively makes sense, but I still need to trace together with you exactly how this happened. Let me just do one more thing for you together with you. Let's say step over. So now we are right before executing this line to create a member object called Yuna, another one, right? So now rather than stepping over, since now what we are doing here is we are calling the customized version of the member constructor over here. Why don't we say step into? Remember the way we use step into from the previous tutorial. Whenever you say step into, you want to step into that particular function or method. And constructor is simply just a special kind of method. Okay. Let's now say step into. Let's predict what's going to happen. What's going to happen is we're going to go into the definition for the customized version for the constructor. And now we actually got options here. We actually got 2 versions of the constructor. You can see in the member class, we got either version number 1, the default constructor that we created explicitly, or version number 2, which will take ID, type, and also balance, right? Which one would it go into? In this case, quite obvious, you will go into this particular context, right? That's a rehearsal before we click on step into. Let's go back to member app 2. And then when we say step into over here, you can see now we are exactly in the first line over here for the member constructor over here, all right? So we're basically creating a new object over here. You can see the new objects, the current object that we're creating is called the context objects. So you can see that's the this what the this really here really means, okay? You can think about the this is really the object we are trying to gradually creating. Initially, we simply got all the 6 attributes over here, but all their values are simply just by default, just default values. And then once we execute each of the 3 assignments over here, we're going to change the attribute values accordingly. Okay, that's what's going to happen. Let's just try. If I say step over, so now I'm now in line number 32. Okay, right before I execute the assignments of ID into ID. Okay, so now you can see ID over here is 1, 2, 3, 4, 6, right? So that means 1, 2, 3, 4, 6 is going to be assigned to the ID over here, which is currently 0, right? Hopefully you can see. All right, so now if I say step over here, you can see the only field, the only attribute that's being modified is highlighted in yellow. So 1, 2, 3, 4, 6, right? For this, for the current object, this. So this is really the Yuna object that we are trying to create, right? We haven't really visualized the process over here, but before I do that, I just want to show you what you can get from the Eclipse debugger. But I'm going to draw that on the paper as well. All right, if I say, what about I execute by clicking on step over again? If I say that it's going to assign the type, at the moment it's actually B, right? The bronze type is going to assign B to the type over here. Currently, it's simply just nothing, right? Let's try that. If I say step over, you can see the B has been assigned to the type over here, right? And let's do one more. What about balance? At the moment, balance is simply just 0.0, and then as soon as I execute line number 34, I'm going to assign balance, which is a 200.0 into that, right? If I say step over, you can see the balance has been assigned to 200.0, right? You can see nothing too much new from what you understood before about how to use debugger. So that's a key point. That's a main lesson I want to show to you first. All right, so now we are happy about how this object has been created, and especially how to call this particular constructor, the customized version. Let me emphasize one more time. It's really important for you to realize that this keyword over here is really talking about the context objects, whatever object that we are currently creating. Or later on, when we call the method, we also need to understand what this is. This really is the current objects we are invoking the method on, right? That's something we also need to emphasize again. All right, so let's now stop the debugger, and then I realize I got some typo over here, right? It should be explicitly, right? Let me just change that quickly. All right, let me now switch back to the Java perspective. All right. So now we have seen exactly how to trace the customized constructor execution using debugger. But now, for completeness, I would like to show you how you can visualize on the paper, which will be very important later on when you actually build your OO program.